Okay, our next lesson is on probability, averages, and counting techniques. This is my favorite concept for the ACT, and the ACT really likes to put them on there. Unfortunately, we don't get a chance to teach you too much about this before you take your ACT, so here's your chance to learn it. Everyone's seen the basic definition for probability, which is number of favorable outcomes divided by number of total outcomes. So Billy has a container filled with jelly beans. It contains 4 red beans, 5 green beans, and 3 yellow beans. What's the probability that Billy will reach in without looking and pull out a red jelly bean? So favorable in this case would be him getting a red jelly bean, and there are 4 of them in the bucket, or a bag, and then, or container. Then total outcomes would be how many total jelly beans we have in there. So let's see, we have 12 total jelly beans. Now, never, ever, ever would the ACT want you to put an answer of 4/12. They always want you to reduce that, which you could either do in your head or math enter on your calculator. So our answer is 1/3. They always want probability as fraction. Reduce fraction. Billy's back to his container of jelly beans. It has 4 red beans, 5 green beans, and 3 yellow beans still. What's the probability that he's going to reach in without looking and pull out any color other than yellow? So favorable this time is anything not yellow. Now there's 2 ways we can do this problem. We can either count up everybody who's not yellow and divide it by the total, or we could use this other probability, which says 1 minus the probability of an event happening will give you the probability of it not happening. So in our case, we could do 1 minus the probability of getting a yellow. So if you do 1 minus the probability of getting a yellow, which is 3/12, and you math entered that on your calculator when you were done, you end up with 3/4. Now this is the same answer that my friends got when they said, well, anything not yellow is 4 plus 5, red and green. So that's 9 out of 12. And when they math entered, they also got 3 out of 4. So either way, your answer is 3 out of 4. Now the reason I tell you this formula is because the ACT has been known to put questions like example number 3 down. If the probability of an event occurring is 3/5, what's the probability of it not occurring? Now they don't actually tell you what this event is or what happens, they only tell you what the probability of it happening is. So we're going to have to use our little formula, 1 minus the probability of it happening, and 1 minus 3/5 is 2/5. And that is either in your head or on your calculator, whatever you are more comfortable with. Compound events, we're going to multiply their probabilities together. Now usually they're independent events, but we'll look at a case where they're not necessarily independent. Jan is flipping a fair coin and rolling a number cube. For some reason they don't call them die, they call them number cube, with 6 sides. What's the probability that the coin will land on tails and the number cube will roll a 4? So since I have 2 events, I'm going to go ahead and draw 2 blanks, and I know I'm going to multiply the probabilities together. So flipping a coin, the probability that that coin will land on tails is always a 1/2 probability. It's either heads or tails. And a number cube has 6 sides, so if it's going to roll a 4, there's only 1 of those on the die. So we're going to say that's a 1 out of 6 probability. 1/2 times 1/6, when you multiply them together, gives you 1/12. Okay, back to Billy and his jelly beans. This time, he's got those same 12 jelly beans. He's going to reach out without looking, grab a green jelly bean, and then he's going to go grab another green jelly bean without replacing the first one. This is a dependent set of events. So we have 2 events still. Let's start with the first event, green jelly bean. There's 5, and remember I think we had 12 jelly beans originally here. Now remember, he took that green jelly bean and put it back on the table. He did not put it back in the container. So now there are only 4 green jelly beans in the bucket, and there's no longer 12. Remember, he took that first one out, so now there's only 11 in there. So if I go ahead and multiply those together, let's see, we end up with 5/33. And that's something you could easily just type on your calculator, 5/12 times 4/11, and then hit math enter to change it to a reduced fraction. Okay, the easiest questions you will ever see are fundamental counting principle questions. All we're going to do is multiply our choices together. These are on the ACT, and they're very easy to do, but for a child who doesn't know how to do them, they might waste a lot of time trying to figure it out. At a restaurant, you can choose from 6 different appetizers, 4 different dinners, and 5 different desserts. How many different meals can you create if you must choose 1 appetizer, 1 dinner, and 1 dessert? Well, the not-so-smart kid's going to sit there and write out all the different combinations. That's going to take forever. The smart ACT student is going to say, well, I have an appetizer, I have a dinner, and I have a dessert. And my choices are 6 of these, 4 of these, and 5 of these. And when I multiply them together, I end up with 120. And that's my answer. Done. Okay, the next question says the science club is going to select one of its 25 members to be president, one to be vice president, and one to be treasurer. Which of the following calculations will provide the number of ways that the officers could be selected? Now, they didn't say this in the problem, but we're going to assume that if you're president, you can't have another office position. So when I go to choose my first person, the president, I can choose from 25 kids. So let's say Sandra is president. Now, Sandra cannot be vice president or treasurer. So when I go to choose vice president, now I only have 24 kids to choose from. And when I go to choose my treasurer, I can't choose either of these first 2 children, so now we have 23 children to choose from. Before you grab your calculator, look at your answer choices. They were written in this sort of notation, so all you have to do is find the right answer, and it is B. They don't actually want you to come up with the number answer. They just want you to come up with the problem setup. Okay, timing overlap problems. We have to look for what's called the least common multiple. So Doug has 2 different medications for his cold. One pill must be taken every 4 hours, and the other pill must be taken every 6 hours. He just took them together, and how many hours will pass before he takes them again? So what I need you guys to do is find the least common multiple of our 2 numbers, 4 and 6. Now, least common multiple is the smallest number that these guys will have in common when you write out their multiples. So the multiples of 4 are 4, 8, 12, 16, and so on. And the multiples of 6 are 6, 12, 18, so on and so on. I think I already know what the answer is, because I think I just said it. It was a 12. However, if you are not sure how to find the least common multiple, what I would like you to do on your TI 83 or 84 is grab your calculator, see if mine will load, and I'm going to show you where on the calculator you can actually find this function. So if you go to the math menu, which is over here on the side, and then go over to the number menu, and then you scroll towards the bottom of the list. Number 8 is called LCM on my calculator. Choose that, and then you're going to type 4, comma, 6. The comma was right above the 7. Once you hit enter, it'll tell you what the least common multiple is for the numbers 4 and 6. So if you're ever unsure, this is another way to do it. Not necessarily faster if you know what you're doing, but it'll save you if you are not confident. All right, moving along. 2 security officers patrol the same building, but at different times. John makes a security sweep every 30 minutes. Diane makes a sweep every 45 minutes. They just both made a sweep together. How many minutes until they go again together? So again, we need to find, we need to find the LCM of 30 and 45. And if you start thinking about multiples of 30, you have 30, 60, 90, 120. And the multiples of 45 are 45, 90. I'm going to stop there because I think I already have my answer. The answer is, 90. But you can easily do this on the calculator using the same math menu function I just showed you in the last problem. Okay, averages. Y'all know how to find an average. You add up all the data values, and then you're going to divide by how many different data values you were given. So a bowling series was 124, 145, and 113. They want to know the average bowling score. So you're going to take 124, you're going to add 145, and you're going to add 113. Now here's the key. Before you divide by 3, you either need to hit enter or you need to use parentheses before dividing by 3, so that way your calculator knows to do the summation before it divides. And the answer comes out to 127.3. Now this is a very typical ACT problem. Marissa has taken 4 math tests so far, and here they are. We're going to assume these are out of 100 points. What will she have to score on her 5th and final test to average a 90? Well, I know to average up 5 tests, I would have to add up all those tests. And if I do that, let's see, I've got 89 plus 95 plus 92 plus 88. Uh-oh, that's only 4 tests. I don't know my 5th test, so in math, when I don't know something, I call it X. And then whatever that sum happens to be, I would divide it by 5, because I have 5 total tests at the end of this problem, and I want my average to come out to a 90. So what I'm going to do next is I'm going to take these 4 test scores and add them all together, which I haven't done yet. 89, 95, which is 364. Still plus x. I can't actually divide that by 5 because it's an expression, but what I am going to do is I'm going to treat this like it's a proportion, and I'm going to cross multiply. So cross multiplying here, 5 times 90 is going to give me 450. So I have 364 plus x equals 450. Oops, running out of room, sorry. When I go ahead and subtract off the 364, I end up with 86. So it turns out Marissa needs an 86. That's the smallest score that she can get in order to average a 90. She could also get a 90 and 91, but that's not the smallest score. The answer choice at the bottom that says cannot be determined is often something that shows up on the ACT. In the many, many years that I've seen an ACT test, I have never actually seen that be the answer. I personally think that when they write a question, they put cannot be determined as one of the answer choices simply because they have run out of ways to screw you up. They can't think of another way to mess this question up, so they just write cannot be determined. And sometimes children think that that's a trick question. They are never that sneaky, so I'm just warning you. Now watch this be the year, but in all my years I've never seen it. That concludes the lesson on probability, averages, and counting techniques.